Hey guys, welcome to our channel. Before starting the video, if you have not subscribed our channel till now, then please subscribe it. In this video, we will see what is Spring Framework and how to create Bean using Bean Factory. So first, see what is Spring Framework. It is an open-source Java platform, and it was initially written by Rod Johnson and was the first release under the Apache 2.0 license in June 2003. It is an application framework and a version of control container for the Java platform. The framework core features can be used by any Java application. It is lightweight because of its POJO implementation. The Spring Framework does not force the programmer to inherit any class or implement any interface. That's why it is said non-invasive. It can be thought of as a framework of frameworks because it provides support to various frameworks such as Struts, Hibernate, Tapestry, EJB, JSF. Loosely coupled and integrated framework for developing enterprise application in Java. What is Bean Factory? It is represented by the interface factory. It is the main and a basic way to access the Spring container. It is built upon factory design pattern that contains a collection of beans. The Bean Factory holds bean definitions of multiple beans within itself and then instantiates the bean whenever asked for by clients. It provides dependency injection or inversion of the control mechanism for the Spring. It is an actual container which instantiates, configures and manages a number of beans. It loads the bean definitions and their property descriptions from some configuration source, for example from XML configuration file. Let's implement. Let's create a new Java project. Make it simple. Project name Spring Core Bean Factory. Here is one simple thing we are doing. So suppose you want to convert your Java project to Maven project, then it's very simple in Eclipse. See, it's done. Let's search Maven dependency for Spring context. Let's copy and paste it into bean.xml file. Now let's check how to write bean.type. Better open Spring documentation. Let's copy this, and to paste this we need an XML file, so let's create one. We will keep this file in resources folder. To make it simple, XML file name beans.xml. Let's copy doctype and paste it in the XML file. Now as you can see, when I type bean, suggestion is coming. So under bean tag, we will declare our bean. Let's create a package. Let's create a simple class called greetings. Let's add one simple variable message. Create getter and setter for message. Let's create one more class called application. Now let's create a bean for greetings. Bean is nothing but an object of greetings class, so instead of creating use new keyword in Spring we create using bean. So under bean two properties, one is it and other is the class. Setting property means calling setter method for message. So this entire code is nothing but equal to this code. Let's create the main method in application class to test this functionality. So now bean factory come to picture. As the name itself, you can correlate like a factory who is creating beans as per the demand called bean factory. So in this case, we are reading bean from XML, so creating an object of XML bean factory class, and need to give XML file name, and that file is available on the class path, so class name class path resource. This class is now deprecated class, but still for learning purpose we can use. Now using getBean method we will read that bean. And as you can see we are holding greeting bean into greetings class variable. Let's print the output, like whatever the value we set from XML it is coming or not. See, it's coming. Let's do one more thing, copy this project and instead of class path let's read an XML file from file system means other than resource folder. So only one code change because now we are reading from file system, so class path resource class no longer works. So there is another class called file system resource. See, the message is coming and it's working fine. Let's review whatever we added. In this video, we will see what is application context and how to create bean using application context. So first, see what is an application context. It is descendant of bean factory and contains some additional functionality. It is an interface for providing configuration information to an application. There are multiple classes provided by Spring Framework that implements this interface and helps us use configuration information in the application. All known super interfaces: Application Event Publisher, Bean Factory, Hierarchical Bean Factory, Listable Bean Factory, Message Source, Resource Loader, Resource Pattern Resolver. All known sub-interfaces: Configurable Application Context, Configurable Portlet Application Context, Configurable Web Application Context, Web Application Context. All no classes: Abstract Application Context, Abstract Refreshable Application Context, Abstract Refreshable Config Application Context, Abstract Refreshable Portlet Application Context, Abstract Refreshable Web Application Context, Abstract XML Application Context, Annotation Config Application Context, Annotation Config Web Application Context, Class Path XML Application Context, File System XML Application Context, Generic Application Context, Generic Groovy Application Context, Generic Web Application Context, Generic XML Application Context, Groovy Web Application Context, Resource Adapter Application Context, Static Application Context, Static portlet application context. Static web application context. XML portlet application context. XML web application context. Let's copy existing Maven project. Make it simple. Project name Spring Core application context. Now instead of Bean Factory, we will use the application context. And we will create an object of class path XML application context because we are reading Bean's XML file from the class path. See, it's working. Now let's read XML from the file system. So now instead of creating object from the class path XML application context, we will use file system XML application context. See, it's working. In this video, we will see what is the difference between Bean Factory and application context. Bean Factory hierarchy. Public interface Bean Factory. Public interface listable Bean Factory extends Bean Factory. Public interface configurable listable Bean Factory extends listable Bean Factory. Autowired capable Bean Factory. Configurable Bean Factory. Public class default listable Bean Factory extends abstract Autowired capable Bean Factory implements configurable listable Bean Factory. Bean definition registry serializable. Public class XML Bean Factory extends default listable Bean Factory. Here is the example you can correlate with Spring Core first video. Application context hierarchy. Public interface application context extends listable Bean Factory. Hierarchical Bean Factory. Message source. Application event publisher. Resource pattern resolver. Public interface configurable application context extends application context. Public abstract class abstract application context extends default resource loader implements configurable application context. Public abstract class abstract refreshable application context extends abstract application context. Public abstract class abstract refreshable config application context extends abstract refreshable application context. Public abstract class abstract XML application context extends abstract refreshable config application context. Public class path XML application context extends abstract XML application context. Here is the example you can correlate with Spring Core second video. Bean Factory. Bean instantiation or wiring. It exists for backward compatibility. Manual Bean post-processor registration. Support lazy loading. It instantiates Bean when you call getBean method. It is okay for testing in non-production use. Application context. Bean instantiation or wiring. Automatic Bean post-processor registration. Automatic Bean Factory post-processor registration. Convenient message source access. Application event publication can publish events to beans that are registered as a listener. Support annotation-based dependency injection. Autowired. Predestroy. Support many enterprise services such JNDI access, EJB integration, remoting. Support aggressive loading. It instantiates Singleton Bean when the container is started. It does not wait for getBean to be called. So here is the difference. Bean Factory do manual Bean post-processor registration. Application context do automatic Bean post-processor registration. Bean Factory support lazy loading. Application context support aggressive loading. Bean Factory does not support the annotation-based dependency injection. Application context support annotation-based dependency injection. Bean Factory does not support internationalization. Application context support internationalization. Bean Factory does not allow configure multiple configuration files. Application context allows configuring multiple configuration files. Let's see practical how Bean Factory support lazy loading. Observe the output. Let's do the same thing for application context. How application context support aggressive loading. Observe the output. In this video, we will see the life cycle of Spring Bean in Bean Post Processor with an example. Let's first see the life cycle of Spring Bean. The life cycle of the bean is easy to understand when a bean is instantiated. It may be required to perform some initialization to get it into a usable state. Similarly, when the bean is no longer required and is removed from the container, some cleanup may be required. You can use init method and destroy method as an attribute in bean configuration file for the bean to perform certain actions upon initialization and destruction. Initialization. Initializing bean interface contains one single method called afterProperties_set. Destruction. Disposable bean interface contains one simple method called destroy. Let's implement. Create a separate project to see the demo for lifecycle. Need to create init and destroy method under greeting class. Method creation is done. As you can see, there are two types of suggestion are coming under bean like init method and destroy method. Pass those method name from which you want to perform initialization and destruction. Let's run and see it's working or not. See, initialize bean message is coming but destroy method message is not coming. So for that need to add something extra. So for that, we need to change application context to abstract application context. Because this class contains one method called register shutdown hook, so this method helps to destroy the bean. See, it's working. Before destroying, it's internally calling doClose method. Instead of calling an it and destroy method for each and every bean, you can keep at beans tag level also, so that will apply for all bean. Let's comment this. As you can see, one is for default init method and other is for default destroy method. See how simple is it? Let's run again. See, it's working. Let's see Spring Bean Post Processors. Bean Post Processor provides a way to perform some operations before creating a Spring Bean and immediately after creating Spring Bean. So you can add some logic before and after creating a bean. Follow steps to implement Spring Bean Post Processor. Implements Bean Post Processor in Processor class. Override methods provided by Bean Post Processor and add some logic whatever you want in post process before initialization and post process after initialization. Create a bean for the class who implement Bean Post Processor in the XML file. Let's implement. First, create a processor class. As I said earlier, this class must implement bean post-processor. Now it's asking for override methods post-process before initialization and post-process after initialization. This time we are just putting some message, but in real-time scenario it will keep some proper logic. That's it for this class. Now let's see how to create an object of processor class using bean. Object creation is done. That's it. Let's run again. See, before and after process initialization method is calling. As you can see, everything is so simple. I hope this helps you to remember this. In this video, we will see what is Application Listener and how to use it. Spring Application Listener. Application Listener can generically declare the event type that it is interested in when registered with the Spring Application context. Events will be filtered accordingly, with the listener getting invoked for matching event objects only. Application events are available since the very beginning of the Spring framework as a mean for loosely coupled components to exchange information. Types of event are available. Start, context started event. Stop, context stopped event. Refresh, context refreshed event. Close, context closed event. Let's implement. Let's copy existing project and create a new project called the listener. Let's create a new package, so under that we will all listener-related classes. Let's first create a class for context start listener. So this class implements application listener interface and context started event as a generic override on application event method. This time we are just keeping message, but in real-time scenario we can keep some logic, so when context start it performs some operation. For this listener class need to create an object using bean. And now we need to call start method from application context object. But this method is not a part of the application context because it's a part of the configurable application context. Let's run and see context start is happening or not. See, the message is coming. Same way, let's create a class for context stop listener. Let's follow the same thing whatever we did for context start listener. And now we need to call stop method from application context object. Let's run and see context stop is happening or not. See, the message is coming. Same way, let's create a class of context close listener. Let's follow the same thing whatever we did for context start and stop the listener. And now we need to call a close method from application context object. Let's run and see context close is happening or not. See the message is coming. Same way, let's create a class for context refresh listener. Let's follow the same thing whatever we did for context start, stop and close listener. Let's run and see context refresh is happening or not. See the message is coming automatically, so before context start refresh is happening. Let's call refresh method manually before the start. Let's run. As you can see, context refresh is happening 2 times. One is automatically other because we added context refresh call. Let's review whatever we added. Hope this video will help you to remember application listener. In this video, we will see what is a custom event and how to create it. Spring custom event. Spring application context provides the functionality to support events and listeners in code. We can create beans that listen for events which are published through our application context. This is achieved via the application event publisher interface. There are a few simple guidelines to follow. The event should extend application event. The publisher should inject an application event publisher object. The listener should implement the application listener interface. For example, password changed event, like whenever password will change, email should trigger on registered mail lid. Let's implement. Let's copy this project and rename as custom event. Let's create a new package for the event. Let's create a new class under event package called user-defined event. As I said earlier, this class must extend application event class. Now it's asking for override something. As you can see, it override the constructor. Let's override string method and put some message. So now for this new event, we need a handler. Let's create a class called the user-defined event handler. This handler must implement application listener, and in generic we will use our user-defined event. If you remember, in the last video we saw start, stop, close and refresh event. Now we need to override on application event method provided by application listener. This time we are just putting a simple message. We created event and event handler. Now we need to create a publisher. Let's create a new package for the publisher. Let's create a new class called user-defined event publisher. So this publisher class must implement application event publisher aware. Now need to override method provided by application event publisher aware. So the method is set application event publisher. Now in this class, we will create variable for application event publisher. Now put this one in the overridden method. Let's create our own publish method, so this method will publish this user-defined event. Now let's create an object for user-defined event and pass publisher object. And publish this user-defined event using application event publisher class. That's it for this class. Now let's create a bean for the user-defined event handler. And one more bean for user-defined event publisher. That's it for this XML. Let's publish this user-defined event from the main method. Let's run and see it's working fine or not. See, it's working fine. Let's add some more messages so we'll come to know the flow. Let's run again. See, all messages are coming properly. You can observe the output. Let's review whatever we added. In this video, we will see types of scope provided by Spring. In the Spring Bean configurations, Bean attribute called scope defines what kind of object has to be created and returned. Here is the syntax. When you create a bean definition, what you are actually creating is an actual instance of the class defined by the bean definition. So you can control object creation using scope attribute. This approach is very powerful and gives you the flexibility to choose the scope of the objects you create through configuration instead of having to the scope of an object at the Java class level. Spring Framework supports 5 scopes. A singleton scope is single bean definition to a single object instance per Spring IOC container. Prototype scope is single bean definition to any number of object instances. The request scopes a single bean definition to the life cycle of a single HTTP request, that is, each and every HTTP request will have its own instance of a bean created off the back of a single bean definition, only valid in the context of a WebAware Spring application context. The session scopes a single bean definition to the life cycle of an HTTP session, only valid in the context of a WebAware Spring application context. The global session scope a single bean definition to the life cycle of a global HTTP session, typically only valid when used in a portlet context, only valid in the context of WebAware Spring application context. The singleton scope. Singleton scope is the default one. Singleton scope should be used for stateless beans. When a bean is a singleton, Only one shared an instance of the bean will be managed, and all requests for beans with an id or ids matching that bean definition will result in that one specific bean instance being returned by the Spring container. When you define a bean definition and it is scoped as a singleton, then the Spring IOC container will create exactly one instance of the object defined by that bean definition. This single instance will be stored in a cache of such singleton beans, and all subsequent requests and references for that named bean will result in the cached object being returned. Singleton example. First of all, beans are singleton by default. If you want, then there is an attribute called scope and set value as a singleton. There is one more attribute called singleton and set value true. Let's implement. Let's copy existing project and make it simple, so name it scopes. Let's run and see it's working fine or not. See it's working fine. Along with message, let's put object itself. Now you can see object also printing with hash code. To check singleton, let's copy existing object, and after run let's see what is it printing. See, both objects are showing the same hash code. That means the new object is not creating. Let's change message for greeting to object. Let's run and see what is the output. As you can see, object hash I code is same, and after change message for greeting two objects and for greeting object message also changed. I hope you understood. So this is the default behavior. Now let's add scope attribute for this bean and set the value singleton. See, still everything is same. Now let's add init and destroy flow also and see when those methods are calling. Let's run again. The only init is calling because not modified code completely. Now run again. See, now destroy is also calling. You are wondering why am I showing all this? Because this will help you to remember when I will change the scope from singleton to prototype. The prototype scope. Prototype scope for all beans that are stateful. Prototype scope of bean deployment results in the creation of a new bean instance every time a request for that specific bean is made. Spring does not manage the complete life cycle of a prototype bean. The container instantiates, configures, decorates and otherwise assembles the prototype object, hands it to the client, and then has no further knowledge of that prototype instance. This means that while initialization lifecycle callback methods will be called on all objects regardless of scope, in the case of prototypes, any configured destruction lifecycle callbacks will not be called. It is the responsibility of the client code to clean up prototype scope objects and release any expansive resources that the prototype beans are holding onto. One possible way to get the Spring container to release resources used by prototype scoped beans is through the use of a custom bean post processor, which would hold a reference to the beans that need to clean up. Prototype example. There is a scope attribute so for that set value as the prototype. For backward compatibility, make it singleton false. Let's implement. Now let's change the scope from singleton to prototype. Let's run and see what is the output. Now you can see both objects have the different hash code and destroy method also not calling, so it's a responsibility of client code to clean up prototype scope, objects or can create custom bean post-processor. Other scopes. The other scopes, namely request, session, and global session, are for use only in web-based applications. If you are using a web-aware Spring application context implementation such as XML web application context, if you try using these next scopes with regular Spring IOC containers such as the XML bean factory or classpath XML application context, you will get an illegal state exception complaining about an unknown bean scope. Other scopes examples. The request Spring container will create a brand new instance of the logic action bean using the login action bean definition for each and every HTTP request. When the request is finished processing, the bean that is scoped to the request will be discarded. The session Spring container will create a brand new instance of the user preferences bean using the user preferences bean definition for the lifetime of single HTTP session. When the HTTP session is eventually discarded, the bean that is scoped to that particular HTTP session will also be discarded. The global session. The global session is similar to the standard HTTP session scope, and really only makes sense in the context of a portlet-based web application. Singleton versus Singleton design pattern. Spring Singleton is described as per container per bean, or Singleton scope in Spring means the single instance in a Spring context. Singleton pattern says that one and only one instance of a particular class will ever be created per class loader. Spring Singleton bean can be any normal class you write, but declaring its scope as Singleton means that Spring will only create one instance and provide its reference to all beans that reference the declared bean. You may have many instances of that class in your application, but only one will be created for that bean. You may even have multiple beans of the same class all declared as Singleton. Each bean will create exactly one instance of the class. A Java Singleton, for the design pattern where instantiation is restricted to one usually per JVM class loader by the code. I hope this video will help you to remember all types of scope provided by Spring. In this video, we will see how to create bean using annotation in Spring. Types of annotations are required. Configuration. Annotating a class with the configuration annotation indicates that the class will be used by Java config as a source of bean definitions. An application may make use of just one configuration annotated class or many. Configuration can be considered the equivalent of XML beans element. Like beans, it provides an opportunity of explicitly set defaults for all unclosed bean definitions. Bean. It is a method-level annotation and a direct analog of the XML bean element. The annotation supports most of the attributes offered by beans such as init method, destroy method, auto-wiring, lazy init, dependency check, depends on in scope. How to declare a bean using annotation. As we saw in the previous video, we declared a bean in bean.xml file. The same way we can do the same thing, so first need to annotate the class as a configuration and then which method is creating an object, so annotate that method as bean. Let's implement. Let's copy existing project and to make it simple name as an annotation. So to add annotation in class, need to do something extra like we need Spring context namespace, then only we can use annotation. Let's check on Spring documentation and copy from there. As you can, there are so many types of example are there, you can use as per your requirement. See, here it is, the context schema. Let's copy this and we'll use in bean.xml file. Now we don't need this bean because we will do the same thing from configuration class. Along with this namespace, we will add one simple configuration called context annotation config. That's it for this XML. Now we are ready to add an annotation at class level. Let's create a new class to add bean related configuration, so make it simple. Class name is bean config, as I shown earlier, so let's annotate this class as configuration. Let's create a new method for creating an object of greeting class. Object creation process is very simple. Now need to annotate this method as bean. Let's run and see it's working or not. It's not working because we completed only half of the working. We need to add those changes in the main method also. Now context class is not at all class path, so instead of that we need to use annotation config application context. No XML as a parameter, so instead of XML we'll pass configuration class, so here class is bean config. Let's run again. See, still not working. Why am I doing the wrong thing again and again? Because it will help you to remember the changes. Again, missed something. Now no bean existing in XML and we already changed application context, so now instead of a greeting, we will use greeting class. Let's run again. I hope this time it will work. See, it is working. Hope you remember all the changes we did. So like we added in scope for the bean in XML, the same thing we can do here also. There is an annotation called scope. Set the value as per the requirement like singleton or prototype. This time I set it a singleton. Let's check it's working or not. See, it's working. Like earlier, let's copy the same object and check still object is one or not. See, it's working. Printing same object, same way. Change it to prototype. Let's run again. See, now it's creating two objects. Let's add multiple config files. Let's copy and create a new project. Make it simple, so name it annotation multiple. Let's create a new package so that will keep all config files. Let's create a new package so that will keep all Pojo classes. Just to make it simple, putting in a separate package. Now let's copy greeting class. We are not doing any changes, just copying. Same way copy bean config as well. So one bean config create a bean for greeting and other configs create a bean for greeting too. Now let's add required changes in application file also. Let's see how to add both the config files. So for this need to change the reference of context, so instead of application context change it to annotation config application context. Remove bean config from the constructor, because there is a method called register. Let's see how to use register with context. The only thing after call register, need to refresh the context. See, that's it. How simple is it to add multiple bean config files? Let's run and see it's working fine or not. See, it's working fine. Let's see all the changes in one slot. Multiple config independent bean. Let's copy again, and to make it simple, name is annotation multiple dependent. To make it simple, let's copy one of greeting class. So to make it dependent on greeting3 class, add reference of greeting class. And now for greeting3 need to create bean, so let's add in bean config class. The code is very simple. In greeting3 we will add reference of greeting create greeting method. And obviously, annotate this method as bean. Let's add required changes in the main method. Before that, let's run. See, it's working fine. Now let's add code for greeting3. See how simple is it? Let's run again and see it's working fine or not. See, it's working fine. Observe the output. For greeting1 only one object is created, greeting3 just using the same because the scope is default singleton. Now let's change it to prototype. Let's run again. Now as you can see, all objects have different hash code. Instead of value, you can also use scope name. Then also the output is same. See, it's working fine in all the cases. In this video, we will see what is Autowire. What is an Autowire in Spring? The Spring container can auto-wire relationships between collaborating beans without using constructor, arg, and property elements, which helps cut down on the amount of XML configuration you write for a big Spring-based application. Auto-wiring modes. No, it is the default auto-wiring mode. It means no auto-wiring by default. By name, the by name mode injects the object dependency according to the name of the bean. In such case, property name and bean name must be same. It internally calls setter method. By type, The by-type mode injects the object dependency according to type, so property name and bean name can be different. It internally calls setter method. Constructor. The constructor mode injects the dependency by calling the constructor of the class. It calls the constructor having a large number of parameters. Autodetect. It is deprecated since Spring 3. Autowire using annotation. To enable annotation to need to add context annotation config in the XML file. The Autowired annotation provides more fine-grained control over where and how the auto-wiring should be accomplished. The Autowired annotation can be used to the Autowire bean on the setter method just like required annotation, constructor, a property or methods with arbitrary names and multiple argument. There may be a situation when you created more than one bean of the same type and want to wire only one of them with a property. In such case you can use qualifier annotation along with Autowired to remove the confusion by specifying which exact bean will be wired. Let's implement. Let's copy existing project and to make it simple name as Autowired. Let's copy greeting class and to make it simple name is greeting2. And greeting instead of message change it to greeting2 and generate getter and setter for greeting2. First, we will see how Autowired work using XML. So before that, let's see what is the code without Autowire. Bean is already there for greeting, so let's change it for greeting2. Let's create a new bean for greeting, as I added reference of greeting2 and added setter and getter in greeting class. So this time I am doing setter injection for greeting2. Now we need to add a reference to greeting2. That's it for the XML file. Let's add required changes in the application class. Let's add some system out for greeting. Let's run and see it's working or not. See it's working. Now let's add system out for greeting2 also. Let's run and see it's working or not. See it's working. Both objects having same hash code means it's by default singleton. Let's add a scope for greeting like prototype. Same thing, let's copy for greeting2 also. Let's run again. See it's working. This time you can see both objects have different hash code means creating object every time. Let's see how to use Autowire in XML. Autowire by name, so after that, I don't need the setter injection, so that will take care of Autowire. Let's run and see it's working or not. See it's working. As you can see, there are so many like no, by name, constructor, autodetect, default. Now change it to by type, so this time it will autowire by reference type, so this time we are using greeting2 class. Let's run and see it's working or not. See it's working fine. Change it to autodetect, so autodetect itself explaining. Let's run and see it's working or not. See it's working fine. Change it to the constructor, so now it expects the constructor in the dependent class. Let's run and see it's working or not. See it's working fine. Same way default also will work. Let's implement Autowired using annotation. So now need to remove Autowire attribute from XML. Let's run and see it's working or not. It's not working now because it's expecting the injected value. Now let's put the Autowired annotation in greeting class because this class is containing the reference of greeting2 class. Let's run and see it's working or not. See, it's not working, because of the need to add context namespace in XML and then enable annotation which we added in the last video. Let's use the same. Let's run and see it's working or not. See, it's working fine. Now let's copy dependent bean and change the id from greeting2 to new greeting. Let's run and see it's working or not. See, it's not working because by default auto wiring is happening by name. So for that need to add one more annotation called qualifier and pass the new name. Let's run and see it's working or not. See, it's not working. Because of the need to change in the main method also from greeting2 to new greeting. Let's run and see it's working or not. See, it's working fine. I hope this video will help you to remember how Autowired works in Spring. I hope you like this video, then please subscribe our channel.